Welcome to the Segments of Circles review. Last one for Unit 9 here. All right, so we're starting off with two things. Number one, we're going to go through the worksheet, talk about how to do the segment lengths, do a little quick review, and then I'll send out a reminder about the rest of the week is to get caught up on your missing assignments. And then Monday we'll be starting a new unit, okay? So we're going to be moving away from the Nearpods, probably into another program. I will get you caught up on that in the future. But here we go. Number one, in the diagram below, diameter AB bisects chord CD at point E in circle F, so F is the center. AE is 2 and FB is 17. Find the length of CE. Now, this is the question where if I have a diameter, okay, that bisects a chord, it's also perpendicular to the chord. So I know that this is going to create a 90-degree angle. It cuts this in half, and we're immediately going to be looking to make a right triangle in this situation. Now I know this is 2, right? FB, which represents a radius, okay, a radius, is 17. All right, and that means FE has to be 15 since the radius is 17. So what we're going to do is we're going to draw in the line from F to C, okay, but a straight line. And we're going to create this right triangle. So to find length of CE, we're just going to be trying to find x here. All right. Now, since CF is a radius, this is also 17, and then I can use Pythagorean theorem. So we're going to use the c squared minus b squared formula. And c is 17. So 17 squared minus 15 squared is equal to a squared. I believe this is 289 minus 225. Okay. And I think this comes out to be, just double checking here. $64. And so this is 8. And so that is also the length of CE. And we're good to go. All right, number 2 in diagram below, circles X and Y have 2 tangent lines drawn from external point D. So this is essentially 2 hat rules, okay? So the points of tangency where you hit the circle are CA, S, and E, and it says the ratio of TA to AC is 2 to 3. So whenever we see the ratio here, remember we're going to put x's on it. So TA is 2x and AC is 3x. All right, now we know this entire line, TS, actually has a length of 35. All right, so TA is 2x and AC is 3x. And so this is our hat rule. So if these 2 tangent lines come from the same point outside the circle, then they have to be equal. So we know that 35 is equal to 3x plus 2x, and then we can solve. So 35 is equal to 5x, which means x is going to equal 7 when we're all said and done after we divide out. And then we want to find the length of SE, which is the same as the 3x. So this is also equal to this, okay, because these 2 pieces are equal because of the hat rule again, okay? So these 2 hats are equal, the 2 big hats are equal, so we're just going to plug in. So SE is equal to 3 times 7, which is 21. Hat rule, people. All right. Going on down the line. Going to the next one. Same thing again. We have 3, 4, and 5 for our ratio. So that tells me the arc LN is 3x, arc NK is 4x, and arc KL is 5x. All right. So on LN we have 3x, NK is 4x, and then 5x. And remember, we're actually trying to find the measure of angle LMK, which is out here. So remember our saying that outside is different. And so we're going to subtract the measure of the 2 arcs formed by this angle. So we're going to subtract the measure of the first arc, which is LN, away from the measure of LK and then take half. So that's what we're going to be looking to do. Okay, so first thing you have to do is find x. So remember, all the arcs together make 360. So 5x plus 3x plus 4x is equal to 360. All right, this is 12x. And so when we divide by 12, we're going to get x is equal to 30. And then when we plug in, 5 times 30 is 150. 3 times 30 is 90. And so now I can figure out the measure of angle M. So angle M is equal to the big arc, right, 150, minus the smaller arc, 90, and then divided by 2. And so this is 60 divided by 2, and this angle just happens to be 30. It's not always going to be the same as x, just happens to be in this case. All right. Number 4, remember we have the chords crossing in the circle. So anytime we have the chords crossing in the circle, we have our similar triangles, which basically means we're going to do part times part. So from this chord, we're going to multiply these two parts together. So ED times EC, and then part times part for the second chord. All right, so we're going to do DE times, now I'm going to move over a little bit because I know what's happening here. We are going to get a quadratic, people. So DE times EC equals BE times EA. So part times part. That's a terrible looking angle, by the way. All right, so here we go. DE is x minus 4 times EC, which is x, equals 3 times 4 on the second one. We get x squared minus 4x equals 12. And then we're going to move the 12 over and get x squared minus 4x minus 12 is equal to 0. So from here, we're going to factor. So I'm going to bring it up here just so we have some room. Okay, so remember, we're looking for two numbers that multiply to give us negative 12 and add or subtract to give us negative 4. So hopefully we're looking for negative 6 and positive 2 to make that happen. So it's x minus 6 times x plus 2 is equal to 0. We do our zero product property. You can drop the wall if you want to, or we just set them both equal to 0. So x minus 6 equals 0, or x plus 2 is equal to 0. So our answer is going to either be 6 or negative 2. Remember, since we're talking about segment lengths, this answer is not possible, okay? So there's no negative lengths. Remember, don't go hating on our negative numbers. Just because it's negative doesn't mean it's got an answer. It won't be an answer, only if it's in terms of angle measures or lengths, or in terms of the question here. So our answer is 6. That's all it's asking for was the value of x. It's not asking for a segment length, so we're done. All right, on to number 5. So we're trying to find length of PA. It happened again, okay? So this is a tangent and a secant. So remember that whenever we see the tangent, we're going to think tangent squared. And if we see the secant, we're going to think outside times the whole segment, okay? So it tells us that PB is 3 and that BC is 15. So the outside piece is 3. The whole is going to be 18. And this is our tangent line from A to P. So we'll call that x for our purposes. So x squared is equal to the outside, which is 3, times the whole, which is 18. So x squared is going to equal 54. And when we square root, we're going to end up with a non-perfect square. So we'll go with simplest radical form here. So x is equal to, and if we break down 54, we're going to get 2 and 27, and then we're going to get 3 3s. So this is equal to the square root of 2 times 3 times 3 times 3. We're going to circle our sets of 3s. So there's a set right here. And we're going to bring one number out from that set. So this is really 9, and the square root of 9 is 3. So this is equal to 3 radical, and the 2 times 3 inside becomes 6. All right, that's it. There's the length of PA. So PA is equal to 3 square root of 6. Now, technically, in a question like this, It doesn't say simple stratical form, so the square root of 54 would be okay, but if it were an exam question, I would expect to see either round to the nearest whatever or simple stratical form. Number 6, we got some more hats going on here. All right, so we have a hat here, we have another hat here, and we have a third hat going on here. So that's what this question is about. So we want to figure out the perimeter, which doesn't make any sense. Instead of segment BC, how about the perimeter of triangle ABC? We'll be able to answer both those questions though. So if AF, we're going to label it one at a time, is AF is 6, that means this segment is equal to this segment, and this is also 6. CD is 5, which means this segment is congruent to this segment, which is 5, and BE is 4, and this segment is equal to this, and so this is 4. So BC, if we're just asking that question, is 9. When we add it all together, right, we should get lengths of 10, 9, and 11. And so the perimeter is at all sides. And so we should end up with 30. So 10 plus 9 plus 11 is 30. And that's the perimeter of our triangle. All right. Question 7 is once again formed outside the circle. So this is going to be a secant line and a secant line. So remember, whenever we see secant lines, we're always thinking the outside times the whole equals the outside times the whole. All right. So it says AE is 14. AC, not drawn to scale by the way, is 24. There's no way this is 10 and that's 14. All right. AB, which is the whole line, is 16, and we're trying to find AD, which we'll call X. All right, so the two outside pieces are going to be AD and AE. They're not equal because they're not tangent lines, okay? So just be aware. So we'll go with the first line, we'll go from the top. The outside is X, the whole is 16, and the outside is 14, and the whole is 24. So we'll just combine like terms. 16X is going to equal numbers. I know it ends in a 6. 336. And then we divide it by 16 and get X is equal to 21. So once again, find AD, which is what we call X. So AD is equal to 21. All right, dropping down to the next one. So we see simple stratical form. We're looking for PA, so we'll call that X. And once again, we have a tangent secant situation. So we know our formula is going to be tangent squared equals outside times the whole. All right, so X squared is equal to, whole is 12, outside is 4, so 4 times 12. So X squared equals 48, and then we're going to go ahead and break this down. So 48, it's even, so it's always divisible by 2. 2 and 24, even again, so 2 and 12, even again, 2 and 6, even again, 2 and 3. So we get 4 2's and a wonderful looking 3 at the end here too. So we're going to do X equals the square root of 4 2's, 2, 2, 2, and 3. And if you want to check it, you could always type it in your calculator. 2 times 2 times 2 times 2 times 3, and it should give you 48. Just a double check. We're going to circle our sets. So we have 2 sets of 2's. Each of these is a 4. So every time we circle and cross out a set, we bring one of those 2's outside. So since there's 2 groups of 2's, there should be 2 2's out front. Or 4, now there's 2 of them, okay, because we took the square root. And then there's a radical 3 left over. And so our answer is, in simplest radical form, 4 radical 3. Now you want to check it, type 4 radical 3 in, type square root of 48 in, make sure they're the same. Should get the same decimal. Okay. Number 9, we have our part times part here. So part times part, part times part. So when we label, We know ED is, for the part times part here, is 6. AE is 4. Okay. We're looking for EB, so we can call that X if you want. And then this guy, CE, is 10. So this is just the case where we have 10, 6, 4, and we don't know, so we just do part times part. Now we could do another option that might pop up. They could tell us the length of CD is something like, 14, and then if this is X, then you would have to do 14 minus X, one of those things. So just be careful whether they're giving you the whole line or the individual segment. We might see a question like that a little bit later, but here we go. So part times part. So we're going to do CE, which is 10, times ED, which is 6, equals 4 times X. So 60 equals 4X. And then divide by 4 to get 15. And so EB is equal to 15. And there we go. And on to the next one, or is that it? That is it, people. So enjoy the rest of your day here. Remember to get caught up on any missing assignments. If you have finished an assignment, please let me know. Maybe the answers didn't stick in Nearpod or something. If you want to send me a picture of it, it's fine. Just let me know and I can give you credit for it. So thanks a lot, guys. Have a great rest of the day.